Okay, welcome to your next set of tutor training videos. These are all about quadratic equations. We're going to go over these three topics. First, how to solve by factoring, the quadratic formula, and then how to graph quadratic functions. So first, a quadratic equation has this general form where you have something being squared, the variable is being squared, right? It's being squared right there. So if you have that, that's how you know it's not a linear equation. We can't just move everything to one side and divide. We have to use different methods. So our first method is to use factoring. Okay, the last three videos you had a lot of factoring practice. So we're going to use factoring now to solve. So we're going to follow this process of method number one, which is to factor. So first, move everything to one side so that you have a zero. It's very important to have a zero when you're solving quadratic equations like this. Okay, check. Step two, factor the polynomial that you get. This is a slope trinomial, so we're going to multiply 5 times 2, use the AC method. You get 10. Factors of 10 that add to be 11 are 10 and 1. Let's go ahead and plug those in. And we're going to chop it, bring back our 0 in a minute. Take out 5x here, and we have x plus 2 left over. Ooh, we can just factor out 1 and it will look the same. So x plus 2. So our factors are x plus 2 and 5x plus 1 equals 0. Next step, set each factor equal to 0. That means if I multiply two things and I get 0, 1, or both of them have to equal 0. So I'm going to take each and set them equal to 0. Oops, don't need the parentheses. Okay, step 4. We have two equations, so we're going to solve each of those two equations. X equals -2 and x equals, subtract 1 divided by 5, so -1/5. So we can plug either of those in and it will give us a true equation. So both of these are correct. So one thing about quadratic equations is they can have up to 2 answers. Alright, that's factoring to solve. Move everything to one side, factor, set each factor equal to 0, and then solve the equations that you have left. Move, factor, 0, solve. But let's talk about what if it doesn't factor. Our next method number 2, is to use perfect squares. Okay, complete the square. We'll get to that in a minute. But let's just say we have x squared minus 8. Okay, that's a binomial. It's a difference, but it is not a difference of squares, nor is it a difference of cubes, because we have x squared. And so we cannot factor it using the factoring methods that we already know. But let's say I move the 8. Something being squared is giving me positive 8. And so if I square root both sides, I can figure out, well, x equals the square root of 8, right? But it could also be true that x equals the negative square root of 8. So I'm going to write plus or minus, right? Either way I square it, I would get x squared is equal to positive 8. And when I subtract 8 from that, I get 0. So either one will work. So if I have something being squared, even on a problem like this, I can square root both sides as long as I remember the plus and the minus. Let's write up this process. So this is using square roots to solve a quadratic equation. Method number 2. Number 1, you have to make sure that you have just x squared or a parenthesis being squared on one side. We'll look at one in a minute that doesn't have that. Square root both sides. Okay, so on the left, I square root 3x minus 7 squared, and I'm left with just 3x minus 7. On the right, I square root 25, and I add the plus or the minus to show that it could be positive 5 or it could be negative 5 to give me positive 25 when I square it. So plus or minus 5. Then I will have two equations, two answers. So I'm going to set it up. It was a little bit like having the two equations on the left slide. It could equal to positive 5 or negative 5. Okay. Step 4, solve both equations. So I'm going to add 7, divide by 3 on this left equation, and I get positive 4. And I add 7 in this case and get positive 2 divided by 3. My two answers are 4 and 2/3. If I plug those in, it will give me 3 times 4 is 12 minus 7. That'd be 5 squared equals 25. 2/3, and I plug in, it's going to give me 25 as well. So both of these work. But what if we have an equation that neither factors nor does it have something being squared? So here's our example, x squared minus 6x plus 4. Nothing multiplies to be positive 4, but it has to be negative 6 in this case, and so I can't get that to factor. And there's not just something being squared, right? If I try to move everything over and square root it, there's still going to be an x on that side. And so I need some way to turn this into something that factors so that it's squared. Okay, keep thinking about that while we look at some perfect squares. You guys remember perfect square trinomials from the last set of videos? Let's talk about those for a minute. So those always factor to be a nice binomial multiplied by itself. So if I multiply x plus 7 times x plus 7, I get x squared plus 14x plus 49. If I multiply x minus 5 squared, I get x squared minus 10x plus 25. Take a second and look for a pattern. Okay, the pattern is, and we talked about this with perfect square trinomials, this thing here is being squared to get the last term, but multiplied by 2 to get the middle term. Right? Negative 5 times 2 is negative 10. Negative 5 times itself is positive 25. Same thing's happening with the 7s. 7 times 2 is 14. 7 squared is 49. But let's say we're going to go the other way around. What could I fill in this parenthesis with to get x squared plus 8x? And what would I put at the end to make it a perfect square? So I'm going to work backwards. Instead of multiplying by 2 to get 8, I'm going to take 8 and divide by 2, or times by 1/2. 8 divided by 2 is 4. Positive 8 divided by 2 is positive 4. And then to fill in and complete this perfect square trinomial, I would then have to take the 4 and square it and get 16. X squared plus 8x plus 16 factors to be x plus 4 times itself, or x plus 4 squared. Alright, this one, even if it's an odd number in the middle, that's okay. So I'm going to take this backwards, and I'm going to go negative 7 times 1/2, or divided by 2. If you want, you can write that as a decimal, negative 3.5. That works as well. And then I'm going to take that and add it on the end. It's negative 7 over 2 squared, or 49 over 4. So if I have something that looks like this problem, I'm going to add something to both sides to make it a perfect square, which is totally okay to do. It's an equation. I can add the same thing to both sides that I want to, as long as it's the same thing and I keep the balance. Okay, first let's move that 4 over, just to get it out of the way. Negative 4. Okay, so x squared minus 6x, I want to add something here to make it so that it factors into a perfect square. And I'm going to take into account the fact that there's a negative 6 here. I'm going to divide that by 2, and it would factor to be x minus 3 squared if I add on a perfect square. So negative 3 squared is positive 9. And what you do to one side of the equation, you have to do the other side of the equation, you get plus 9. Okay, let me explain that one more time. I know that I had to have a negative 6 in my multiplied answer. So I took that, divided by 2, that gives me negative 3. And I'm going to add on plus 9, because x squared minus 6x by itself doesn't factor to be x minus 3 squared. And so I have to add on that 9 to make that true. Because really what I'm saying is, now I have this, and I'm going to factor that, and I get x minus 3 squared, right? Because that will multiply to be 9 and add to be negative 6. And because I added on both sides, I didn't change the equation. I just made it look different. Okay, from here, I can follow the steps from the previous slide of taking the square root, both sides. I get x minus 3 equals plus or minus the square root of 5. And x equals 3, moving that over, plus or minus the square root of 5. Ta-da! And if you want to write that as separate, some students prefer that. That's okay too. There's my 2 answers. Okay, let's summarize this process of completing the square and then using that to solve. So it's over here. I gotta clean up my mess here. First, you have to have at the beginning just x squared. It needs to be a trinomial with just x squared at the beginning. Okay, so let's go ahead and do this process with this problem here. So 5x squared plus 3x minus 1 equals 0. Okay, first step, if necessary, divide by a to make the leading coefficient 1. Right? A is mean this number in front of x squared. The reason for that is we only talked about this process if there's just an x squared at the beginning. So we're just going to do that. Get rid of it. It's going to give us some fractions, but that's okay. Divide everything by 5. So that's 3/5 x. I'm also going to move the 1 over. I'm skipping a step. But divide by 5 and then add 1/5 to the right side. And I'm leaving that big little gap after 3/5 x for a reason. So 2 we already did. Move the constant to one side. And then we're going to find b, meaning the middle term, divided by 2. So let's just write that. That's going to be 3/5 divided by 2 or times by 1/2. So that's 3/10. Okay, we found it. Number 4 says add b over 2 squared to both sides. So far we're at x squared plus 3/5 x. I'm going to add 3/10 squared to both sides. Okay, on the left, we know from how we set it up that that's going to factor as a perfect square over here. And let's simplify the right side. 1/5 is really 20 over 100. 3/10 is 9 over 100. So 29 1/100ths on this side. Okay, now we have a perfect square. This is step 5. We've factored it into a perfect square, and now we can solve it using square roots like we did in the last problem. So square root, remember to do your plus or minus on that side. So x plus 3/10 is equal to plus or minus the square root of 29 hundredths, and the square root of 100 is 10. So let's go ahead and subtract 3/10. Negative 3/10 plus or minus the square root of 29 over 10. So this gives us one option of how to solve quadratic equations when they don't factor. Of course, you can always check every time to see if they factor. This one didn't. This last one that we did. So we had to use something else. Completing the square is how we were able to figure that out. Next, we'll talk about another method in the next video.